Modeling a shrouded header. Using the recommended PCB LAN pattern from the manufacturer, along with the standard ZIF calculator, and a variant being the drill hole versus a surface mount hole, which we will automate and replace with the pad stack calculator. Reviewing the datasheet, we have 2 rows, 10 surface mount pads per row, with 2 drill hole throughs or mounting holes in the center of the device. Let's start by bringing up the calculator. Using the connectors catalog and the individual type of connectors and calculators, we will select the ZIF calculator for our surface mount devices. Selecting the component tab and changing the number of rows to 2 and the number of pins on the side to 10. To change the offset, we will toggle the negative to 0 and align the 2 columns with the first to the second column. Clicking on the D field directly on the screen, we will use the associative editor to change the value of the width of the component device, and the A column or the A entry to change the column tab form dynamically directly on the screen to the specific width. Next, let's change the center-to-center spacing of the 2 mounting holes. From the datasheet, it's 16.0. Clicking Calculate will recalculate the spacing. Next, let's change the pin pitch to 2.0 and 4.25 in the Y direction. Selecting Generate will insert the proper spacing per the rules and grid locations, and changing the X and Y direction of the pad. Reviewing the datasheet, we have 2 mounting holes with a diameter of 1.00. Under Pad, select the pad stack calculator. Selecting the calculator, we have 2 generated pads that are currently used in the part. Select New Pad to create a variant or third pad, changing the type of device to through hole with this specific pad. Next, let's change the pad shape to circle and selecting Generate, and the drill size diameter to 1.0. With an annular ring of 0, we'll generate a through-hole pad. To obtain a spotter pad on this particular device, change the annular ring to a negative amount. In this case, I will change it to negative 0.2, selecting Generate. Using the pad stack calculator, we can automate and edit all different variances of the pad stack geometries. I will now save the pad stack as a variant, giving the new pad stack name the generated name for the IPC definitions _V for a variant indicator. To map, select Mapping. Click on the 2 pins that I wish to swap. Clicking on the selected device, select Swap Selected Pads in the layout view. The footprint builder generator is reentrant. Selecting Generate, we can use the same modifications or variances and apply the standard rules and regenerate any geometries which were impacted by the variant changes. I'm now ready to export the pad to Allegro along with the part geometries. Bringing the part up in Allegro, notice that the 2 spotter holes are set up for the drill locations. Had I needed to change the pin location, I could use the rotated, mirror horizontal, and mirror vertical to orientate the pin locations to the exact location. Pin 1 in this case will be generated at 0.0. In this training video, we demonstrated using the standard surface mount calculator for the ZIF device and a recommended PCB LAN pattern provided by the manufacturer. We also use the pad stack calculator to automate the through-hole pad stack or mounting locations, which were variances to the standard calculator, and the ability to regenerate using these variances with the reentrant calculator.